Descriptive statistics in business management are techniques that help convert raw data into meaningful insights by summarizing, organizing, and visually presenting information. By turning complex numbers into straightforward charts, averages, and summaries, descriptive statistics support informed and effective decision making within organizations. These statistical techniques help make sense of complex data by identifying key patterns and differences. This video will focus on standard deviation. Standard deviation is one of the most powerful tools in descriptive statistics for understanding data variability in a business context. Rather than simply reporting an average, standard deviation reveals how much individual data points, such as weekly sales figures, cluster around or deviate from the mean. If you've been watching our video series, you have heard of Roast and Vibe, the fictional coffee shop based in Dublin that we are using as our practical example. Like many businesses, Roast and Vibe uses various external and internal environmental tools to support its decision making. For businesses like Roast and Vibe, it is not enough to know the average sales. It needs to know whether that average is a result of steady business or conceals dramatic fluctuations week to week. To gain these insights, Roast and Vibe wants to calculate the standard deviation of its sales over a 6-week period, helping them to understand how consistent or variable their sales performance really is. The calculation of standard deviation begins with the mean of the dataset. In this case, the total sales over 6 weeks divided by the number of weeks. Each individual data point is measured against that mean by calculating its deviation. Whether a week's sales are above or below the average, the deviation quantifies how different it is. These differences are then squared so that they all contribute positively to variability, avoiding cancellation between high and low points. Once we have squared all deviations, we sum them and divide by the number of data points to find the variance. The variance gives a sense of total variability, but because it's expressed in squared units, we take the square root to return to the original units, producing the standard deviation. Let's go through each process step by step. First, you begin by calculating the mean. If you'd like a more detailed explanation of how to find the mean, refer to the dedicated video earlier in this series. The first step is to add the sales together. Next, we need to know how many pieces of data there are in the dataset, as we will use this to find the average. In this case, the data relates to sales over 6 weeks. Now we find the mean average by dividing the total sales by the number of weeks. This gives us the mean. The next step is to calculate the deviation from the mean. The deviation from the mean tells you how far each number is from the average, or the mean, of all of the numbers. In order to calculate the deviation from the mean, we subtract the mean from each number in the dataset, which in this case is weekly sales. The calculation for week 1 would be €4,000 minus 3,725, giving a deviation from the mean of €275. The calculation for week 2 is €3,750 minus 3,725 euro, which gives a deviation from the mean of €25. Repeat this process for each week in the dataset until you have the deviation from the mean for weeks 1 to 6. Next, for each data point, square the deviation from the mean. To square something means to multiply it by itself. For example, for week 1, this is equal to 275 times 275. For week 2, it's 25 by 25, and so on. Next, we need to find the average of the squared differences. We do this by adding the squared deviations and divide by the number of items in the dataset. This gives us €148,958 and 33 cents. Finally, find the square root of the average of the squared differences to determine the standard deviation. In this case, the deviation from the mean is €385.95. This means that on average, weekly sales vary by about €386 from the mean of €3,725. What this means for Roast and Vibe is that most weeks, sales are likely between €3,725 plus or minus €386. This puts their sales roughly between €3,340 and €4,110. This means that Roast and Vibe has moderate variation. Their sales are not perfectly stable, but they're not wildly unpredictable either. So the standard deviation tells you how spread the sales are around the mean. A small standard deviation means that sales are quite consistent, meaning that they don't change much from week to week. A large standard deviation means that sales are unstable or unpredictable. Some weeks are much higher or lower than others. It's important to ask yourself why this information is useful to a business like Roast and Vibe. If the standard deviation is high, managers will see that customer numbers and purchases vary widely from week to week. This can highlight seasonal effects, local events, weather changes, or even the impact of marketing campaigns, which helps the shop anticipate busy or quiet periods more accurately. A low standard deviation allows Roast and Vibe to schedule staff and order supplies with confidence, reducing the risk of overstaffing or running out of ingredients. If the standard deviation is high, they know to adopt flexible staffing and inventory plans to handle unpredictable weeks and avoid waste. Finally, monitoring the standard deviation over time helps managers in Roast and Vibe assess the effectiveness of sales promotions or pricing changes. If a new offer leads to greater sales variability, they can investigate whether that volatility is positive, leading to higher revenue, or negative, leading to sharper drops when their promotions end. This wraps up our exploration of standard deviation, but this is just the beginning. This video is part of a broader series designed to build your confidence in using descriptive statistics and analytics to solve real-world problems. Thanks for watching, and I'll see you in the next one.